All right, let's get into it. Today we are talking about a word that you have probably heard thrown around a ton in the tech world, Docker. It's a tool that has, and I'm not exaggerating here, completely changed how we build and, maybe more importantly, how we ship software. So what is it really, and why should you care? Well, let's find out. Oh, you know this one. We've all been there. A developer is showing off their work, it's running perfectly on their laptop, but the second you try to run it anywhere else, nope, it just breaks. That one single, incredibly frustrating sentence is really the key to understanding why Docker even exists. And yeah, that phrase isn't just a funny little annoyance. It's actually a symptom of a much, much bigger problem in software development. It's what developers call the nightmare of inconsistent environments. So what does that actually mean? Well, think about it. The software on a developer's computer might be just slightly different than the software on the server where the app is supposed to live. Maybe it's a different version of a library or just one tiny system setting, but that's all it takes. That one little difference can cause the whole thing to crash, and that leads to hours, sometimes days of hunting for bugs. It's a recipe for delays and a lot of headaches. So how do you fix a problem like that? Well, the solution is kind of brilliant, and it's based on an idea that totally changed the physical world way before the digital one. We're going to use a little analogy here, shipping containers, but for code. So, picture a port before the 1950s. It was total chaos. You had barrels, you had sacks, crates, loose stuff. Everything was a different size, a different shape. Loading a ship was this slow, expensive, and super complicated puzzle.
I mean, it was a logistical nightmare.
And then this thing came along. This simple, kind of boring, standardized shipping container. And all of a sudden, it didn't matter what you were shipping. Bananas, car parts, you name it. Everything fit inside the exact same box. And that same box could be moved by the same cranes, onto the same trucks, and onto the same ships, anywhere on Earth. It completely revolutionized global trade. And that right there, that is exactly what Docker does. Docker gives us that same standardized box, but it's for our code. It neatly packages up a piece of software and everything, I mean everything it needs to run, all into a single portable unit that you can ship and run absolutely anywhere with no surprises. Okay, so now that we've got that picture in our heads, let's get a little more formal. What is Docker, really? So at its core, Docker is an open platform for doing three main things: developing, shipping, and running applications. And the way it does all that is by using those special packages we just talked about, which are called containers. So what's actually packed inside that box? Well, a container holds not just the app's code, but the whole shebang. We're talking about the runtime, the specific system tools it needs, the exact versions of all the libraries. All of it is sealed up inside, guaranteed to be the same every single time. You know, for all its impact, Docker isn't actually that old. It first came out back in 2013, created by a team led by Solomon Hykes. And for any of you curious tech folks out there, it's written in a programming language called Go, which is known for being super efficient. Okay, so we know what it is, but what's the big deal? Why did this one idea pretty much take over the entire software world? Well, it all comes back to two magic words: consistency and portability. Because everything the app needs to live is packed right inside that container. That whole "it works on my machine" problem, it just disappears, gone. If it runs in a container on your laptop, you can be sure it's going to run in that exact same container on a server, in the cloud, or anywhere else. It's truly write once, run anywhere. Now, to really get why this is such a game changer, you have to compare it to the old way of doing things, with something called virtual machines, or VMs. A VM is, well, it's heavyweight. For every single app, it has to include a full copy of an entire operating system. It's like packing your entire house just for a weekend trip. It works, but it's slow and takes up a ton of space. But containers, they are way, way smarter. They share the operating system of the machine they're on, so they only need to package the app itself. This makes them incredibly light and incredibly fast. They use way fewer resources and can start up in, like, an instant. And all of that efficiency, well, it translates directly into speed. Developers can get their applications out the door so much faster. And if an app suddenly gets popular, they can scale it up to handle more users in seconds, not minutes or hours. It also plugs perfectly into all the modern automated systems for building and testing software, something you'll often hear called CI/CD. All right, so you might be thinking this all sounds a little magical, maybe a bit complicated, but how it actually works is surprisingly straightforward. Let's peek inside the toolbox. It really just boils down to a simple 3-step recipe. So here's how it works. Everything starts with a simple text file called a Docker file.
Just think of this as the recipe or the blueprint. It has all the instructions. Then you give that blueprint to Docker, and it builds something called an image. The image is the template, the actual package with everything inside. And finally, you tell Docker to run that image, and poof, you get a container. That's your app, live and running. So it's just blueprint to template to running app. That's
There's a quote that just sums this all up perfectly. Docker can package an application and its dependencies in a virtual container that can run on any Linux, Windows, or Mac OS computer. That's the whole magic right there. It takes away all the guesswork. It takes away all the what ifs. That is a seriously powerful idea. So when you boil it all down, Docker's big revolution was standardizing the package. It made shipping software reliable, predictable, and universal. It solved a giant logistics problem for the digital world, which kind of leaves us with a really interesting question to chew on. What's the next big idea out there that's going to fundamentally change not just how we ship our software, but how we build it in the first place?